Okay, let's start with how to make questions easier in terms of how to pick out the formula and how to use the formula. So the first thing you want to do is look at the topic. We're looking at simple harmonic motion. That will limit the amount of formula that we're going to be dealing with. So it limits it to these four formula. These are typically the four formula that will come up for a simple harmonic motion question. And then the next thing you need to do in a question is ask yourself, what's happening in the question? And can we apply any or all of those to the particular question? Now, there are some unusual questions, like number 4, for example. We're given the maximum force acting on a particle is 60 newtons. The mass of a particle is 12 kgs. If the acceleration of the particle is 1 meters per second squared, when the displacement from the equilibrium is that, find the amplitude of motion. So with questions like that, you're going to have to draw some sort of diagram. And we know that there's an extreme, and the particle goes from one extreme to the other and back again. So that's a full period, right? Just as a bit of a recap. It's the time taken to go from one extreme up to the other and back again. Where the distance from, that's the center of oscillation or the center of vibration. It's halfway between the two extremes. Where the distance from there to an extreme is an amplitude. Look, an amplitude. So that's an amplitude. That's also an amplitude. And what you need to remember here with question 4 is the force is equal to a maximum at the extremes. That's where the acceleration is equal to a maximum because F is proportional to A. And look, that's just a bit of extra stuff that you need to know, right? So if the force is a maximum, it means the acceleration is a maximum. And hopefully that would make sense because if A is equal to minus omega squared S, what we have at the extremes is the maximum displacement, is the amplitude. So we get the maximum acceleration is minus omega squared times the maximum displacement, which I can call the amplitude there as well. It's all the same thing, just given different words to explain it. So with question 4, what we're told to, first of all, is there's a maximum force of 60 newtons and there's a mass of 12. So I use F is equal to ma there. That allows me to get the maximum acceleration of 5 meters per second. Remember, that happens at the extreme, and that's part A in the question. We're looking for the amplitude, and I need the acceleration at the amplitude in order to be able to work through it. What I also need for the amplitude is the omega squared value. There we go. So I have the acceleration, the maximum acceleration. I need the omega squared value in order to get the A. And the next part of the question gives us an acceleration and a displacement. So when you put it into A is equal to minus omega squared S, ignoring the sign, you get omega squared is 10. And then to solve question 4, put in the 10 for omega squared, put in the 5 for A, just like I have there on the right-hand side, and the amplitude works out as 0.5. So 3 steps. Now, you're probably going to be looking for some way to guide this, right? First of all, your understanding has to come from this. The maximum acceleration occurs at the amplitude. In order to get the amplitude, I need the other 2 values. To get that value, F is equal to ma. To get that, I need to use the other condition that I'm given. All right. Now, let's have a look at the homework questions. So, question 1 and 2, I've written down that they're relatively easy. It's not necessarily the case, but they're easier than the rest of them. What you need to remember is the time taken for one oscillation is a period. So if you knew that 20 oscillations took 4 seconds, then if you divide the 4 seconds by 20, you'd get the periodic time. There we go. I didn't put it in the video, but anyway. To calculate the frequency, then it'd be 1 over the period, and the frequency for that, even though it's not asked in the question, would be 20 over 4, which is 5. And look, the units of frequency are called the hertz. Don't worry about that for now. Okay, for 6, 7, and 8, I'll give you a tip. Hopefully the tip will be enough to get you finished on it. If you're given the periodic time, let me try and focus that. If you're given the periodic time, you should be able to find W straight away from T is equal to 2 pi over W, or omega. And likewise, sometimes if you're given W, you're asked to get T. Let me fix that. Using that formula. So that formula will allow you to go from the period to omega. It's quite useful. All right, good luck with it.